Aloha class. Today we are in section 4.4, factoring quadratic expressions. Home's going to tell you that without a doubt, this is one of the most important lessons that we get to all year because it's a foundation and it's going to build for the rest of the year. So let's get that title down. Let's get that objective down. All right, we're going to factor some trinomials and we're going to make them into a couple of binomials. And all math ever is about going forward. So if you remember the little FOIL method you used to do, that used to be two binomials that made a trinomial. Now we're going backwards. And we're going to take that trinomial and we're going to create two binomials, okay? Now here we go. We're going to start a little nice and easy, Japanese. Now what makes these factoring problems nice and easy, Japanese? It's because we're going to start with a leading coefficient of ichi. And whenever you do that, you can do these super fast way, which is really, really nice. Now, one thing we always do when we factor is this is called a trinomial. Why? Because it's three terms. And whenever you have terms and we're dealing with factoring, we always want to see if all three of them have something in common. Now, these three, x squared, 9x, and 20 have nothing in common other than ichi, right? All of them have a ichi in it, 1 times. Everything always has a 1 in it. So whenever they don't have anything in common and it's a trinomial, which is a quadratic, we always go to our little side work method on these problems, okay? Now, when we do our side work, what we're going to do is in this top little part of the x right here, we're going to multiply the first coefficient by the last guy. So we do 1 times 20, which is 20. Okay, make sure you're taking good notes. In the bottom, we put whatever number is the coefficient of the middle guy, which is a 9er. Okay, and then what we do is we try to find out all the different ways that we can get 20. A lot of ways you can get 20. 1 times 20, right? Let's put a 1 and a 20 in there. And 1 and 20 works if when you multiply those two numbers, 1 and 20, you get 20. Good, check 1, but you got to get 2 checks. And when you combine them, a 1 combined with a 20 addition gives me 21. Does not give me 9. Okay, so we want to find what we call factors of 20. Then when we multiply, we get 20, but when we combine, we get 9. So does anybody at home know? Oh, somebody said 2 and 10. Does that work? For sure it works because 2 times 10 is 20. Yes! But 2 plus 10 is 12. Doesn't work. Nice try, Mr. T. I know some of you are yelling at me. Stay easy. Stay cool. 4 and 5. That works. How do I know that works? Because 4 times 5 is 20, and 4 plus 5 is 9er. So when it works, we can do these the super duper fast way. What do I mean by super duper fast? This is what I mean. How do you get x squared when you FOIL? It's x times x. So when you can do these the super duper fast way, that's all you have to do. And then you say to yourself, oh, how do we get 20? It's a plus 4 and a plus 5. And believe it or not, if you FOIL that guy out first, outside, inside, last, distribute all that bad boy stuff, you will get this as your answer. How about it? How was it, class? Bad, not bad? Well, if it was bad, don't worry. We're going to do 3 more of these guys. Actually, 2 more of these guys, okay? We're going to do B and we're going to do C. All right, let's go ahead and do B here. We got x squared minus 11x plus 30. Once again, I've got 3 of those guys. They have nothing in common other than a common factor of 1. It's a 1x squared leading off, so that means we can do our little side work, schling, right? We can do it the super duper fast way. And then I have to find factors of 30. Well, how the heck do I get 30? Whoa, slow down, Mr. T. I have to put what goes on the top and the bottom. 1 times 30 is 30. And then the middle guy, ooh, it's a negative 11. Oh, well, how do I get 30? Well, that's easy. That's 3 times 10. All right, so let's put a 3 and a 10 right there. But if I combine those guys, I get 13. And I got to get a negative 11. What the heck? How do I get a negative 11? Well, let's think about this. Oh, yeah. A 5 and a 6 gives me a 30. And a 5 and a 6 gives me, oh, snap, a positive 11. Well, here's the trick. If you do this little technique and these two guys equal what you want up here, 5 and 6, but they combine to almost get this dude, but the signs change. All you got to do is change the sign. So if that's positive, make it negative. That's positive, make it negative. And oh, sweetie, sweet, it works because a -5 times a -6 is a positive 30. And if you combine those two bad boys, you get a -11. So sweetie, that's a 1. So I can do this the super duper fast way. What's that mean? XX. And then a -5 and a -6. Booyah, dunzo, let's go. Give me them toes, right? All right. Now there's definitely a curveball thrown into C. What is the curveball at home? What do you think it is? Good job. Homie said there's a negative sign out there in front. So can I, Mr. T, can I do this the super duper fast way? If there's a negative out there, and believe it or not, you can, we just rewrite the problem and take the negative out of everything. If I take the negative out of everything, it just changes the sign. Whoop, that was a plus. Come on now. That's a plus. It changes the sign of everything. Okay? And then you pretend like that negative out is on the outside. That dude's just hanging out by himself, and you factor that. It's got 3 terms. The 3 terms have nothing in common. There is that magical 1 out in front, which is awesome because then we can just do it the super duper fast way. Well, how do I do that, Mr. T? Well, you multiply the first guy, and the first guy is just a 1 because the negative is on the outside, times a -32, which is -32. And then the middle guy is a -14. Well, how the heck do you factor to get a -32? Well, if it's a -32, one of my guys would have to be negative, right? It would have to be. And I know the first thing that comes to my head would be a 4 and an 8. But a 4 and an 8, if one of them had to be negative, right? A 4 and an 8. One of them have to be negative. Let's make that negative. But if I combine them, I get a -4, and that says a -14. Okay, so I know that guy can't work. So then I got to think of something else here. And one thing, it's an even number, so that means I could take half of it in 2 and 16, right? Okay, so let's try that. A 16 and a -2. That definitely multiplies to be -32. But when I combine them, I get a +14. And what did I say the problem before? If when you combine them, you get this number down here, but the sign's different, what do you do at home? You change the signs. So let's make that a negative and that a positive. And now it works out beautifully. That negative's just hanging on. And I do this part the super duper fast way, which is x and x, -16 plus 2. Dunzo! Good job at home if you guys were able to do that. Now, my next page is going to have a bunch of problems. What I encourage you to do is hit pause, okay, and try some of those bad boys. Okay, and if you're feeling confident, you're getting a lot of these right, you're doing an awesome job. If you're really struggling with some of those practice problems, make sure you see me tomorrow for help. Okay, now how is this dude a little bit different from all that we've been doing? Well, we're going to introduce this very important concept of GCF. And that is, I have 2 terms here, so we're not going to do this a super duper fast way. We're not going to make a little X off to the side. Okay, all we have to do here is just compare those 2 guys. And do they have any factors that are common? Right? If you look at that 6 and the 9, well, 6 is 2 times 3. 9 is 3 times 3. They both have a 3 in it. So we want to always take out what's the greatest common factor. And they both do have a 3, so we take out a 3. Okay, they also both have at least one n in it, so we factor out that also. And this is just our most basic form of factoring, where we always factor out what is the greatest common factor. So what do they have in common? We have to make sure it's the greatest. So we take out that 3 and we take out that n. Now remember, factoring is going backwards. So instead of distributing, which is multiplying, we're going backwards, which would be division. All right, so when we factor, we divide. All right, so you take this and divide that by 3n, right? If you do 6 divided by 3, I get 2. And if I do n squared divided by n, I get n. And then that plus sign carries on. And then once again, factoring out, dividing. 9 divided by 3 is 3. Whoops, 3. And then n divided by n, it's gone. And then that's donezo. And guess what? You can distribute, and you should always get the same thing you started with. Beauty about math. Can always, always check your work. It's beautiful. All right, here we go. Let's practice some of these guys here. All right, we have 7n squared minus 21. There's just 2 terms. There's definitely something in common. What's common, class? Boom. Great job. 7. Okay, a 7's common. I mean, if I take a 7 out, 7 divided by 7 is 1, but you're going to be left with your variables, which is n squared. Negative carries on. 21 divided by 7 is 3. Now, you should always ask yourself, can I keep on going? Pretty soon, we're going to have to keep on going. Okay, but for right now, boom, that's our final answer. Okay, let's go to B. This will be an example of maybe keep on going. This time, there are 3 things. Can I do it the super duper fast way? At home, you should be saying, no way, Mr. T, there's a 9 there. But what have I not done yet? Do those 3 things have something in common? For sure they do. They all have a 9, right? They actually all have 3s, right? 9 has a 3 in it. 3 times 3, 3 times 3, 3 times 6. But there's something greater than 3, which is 9. Okay, so you always have to take out the greatest common factor. Now, these 2 guys have x's, but the last one doesn't, so we don't take out any of the x's. Remember, if we divide all of these, this is what we get. Okay, now, it looks like maybe I can go on. Well, if you can go on, you better check that. Okay, so let's check it. That is a 1 now, right? That 9's just on the outside hanging on, so let's check it. How do I check it? Well, I do the side, what? And if I can work out this x, that means I got to keep on going on. So let's check it out. 1 times -2, right? That's what goes here, which is -2. And the bottom is a 1. Is there any way that I can work this out? Well, let's see. Oh, sweet. Yeah, -2 times 1. Well, -2 times 1 is -2 when I multiply. But when I combine them, I get a -1, but I want a +1. And Mr. Tanaka said, when it's exactly what you want, well, not exactly. When it's the number you want, but the sign is different, just change the signs. And if it works out, then that means you got to keep on going. XX. And then there was a +2 up there and a -1. Dunzo! Sweetie, sweet! Now, your goal at home is to hit the pause button and to try C on your own. Challenge yourself. All right. I really hope you guys hit that pause button. Okay, and you tried it on your own. That's how you learn the most. Okay, can I do this one the super duper fast way? No, Mr. T, there's a fault leading off. However, every single one of these has a fault in it. Actually, they all have a 2 in it, right? But what do we have to do? We have to take out the greatest common factor, which would be a fault. Okay, so we take out that 4. They almost all have x's, but they do not. Remember, when you factor out its division, so that's all I'm doing right now. Oh, that definitely looks like I can go on. All right. Let's check it. Side work. Spling, spling. 1 times 3 is 3. 2 right there. Okay, how do I get 3? 3, that's 3 times 1, Mr. T. Oh, snap, but that gives me 4. There is nothing, no way. Don't make magic. There's nothing that works. And so if there's nothing that works, then that means that problem is done. Very important to make sure you pay attention to. Okay? All right. Now we're going to get a little crazy. I think we're going to some, okay, those are all practice problems too, okay? Make sure you practice them. Come in for help if you're really struggling. All right, now, put on those big boy pants. All right, we are going to do these guys now where there's nothing in common, and we can't do it the super duper fast way. Why can I not do it the super duper fast way? Because there's that 2 that's out there in front. All right, but you know what's cool is we kind of get this thing started the same way as always. But this time it's not 1 times 12, it's 2 times 12, right? 2 times 12, which is 24. And in the middle, I got an 11. Well, what works? There's a lot of ways to get 24. 24 and 1, 2 and 12, 6 and 4. But an 8 and 3 is what works. Now, how did I know that? Because 8 times 3 is 24. And if you combine those guys, you get that 11. All right, so how do I do this one? All right, well, let's check it out. This is the method. It's called Nazca Product. Okay, you write down the first dude. All right, you write down the last dude. Instead of writing the middle guy, though, which has an x in it, we're going to write a different way how to get 11x, which would be these 2 guys, right? You could get 11x by adding an 8x and a 3x. Okay, and then we're going to do this very important technique called factor by grouping, which you're going to take these first 2 guys, All right. And just focus on those first two guys. And we're going to factor out a greatest common factor. They both have a 2 and they both have an x. And remember, when we factor, it's the opposite of FOILing or distributing, which is multiplication. So we divide. 2x squared divided by 2x is x. 8x divided by 2x is 4. And then that guy separates my two groups. So I got to make sure I carry that sign down. Now, what's common between a 3x and a 12? Well, a 3, Mr. T. And then what's left? An x, and a plus 12 divided by 3 is 4. Do you notice anything in common? I sure do. They both. That's one of the terms. That's one of the terms. What do you notice about both of those terms? They both have a common factor of an x plus 4. So we're going to factor that guy out now, and then don't relax, then we're going to be done. Okay, so if I take this out of both of those, what's left, class? A 2x and a plus 3. And then that is it. Doesn't get any tougher than that. If you just were able to understand and follow what went on right there, you are going to be good to go. Now, I know we've got to do at least one more of these bad boys. When you can't do it the super duper fast way, it definitely gets a little more difficult. Okay, here we go. One more together, and then you guys need to challenge yourselves and see if you can do B all by yourself. I got 3 guys. First thing I should check is, do all 3 have something in common? No way, Jose, Mr. T. So then we can't do it the super duper fast way, but we still go with this little x method, okay? But instead of 1 times 3, that's a 4. So we got to do 4 times 3, which is 12. The middle guy is 7, okay? A lot of ways to get 12. 12 and 1, 2 and 6, 3 and 4. Why does that work? Because 3 times 4 gives me the top number, and 3 plus 4 gives me the bottom number. So how do we do this little master product that I just showed you? You write down the first dude, you write down the last dude. You write down another way to get 7x. How can I get 7x? Well, you get 7x by adding a 3x with a 4x. Okay? And believe it or not, it doesn't matter what order. You could put that 3x or the 4x, and you could flip-flop those guys. Okay? There's always a couple ways to do these problems, all right? But we're all going to get the same answer in the end, okay? So then what we do now, remember, is we group those 2 together, and we group those 2 together, separated by that plus sign. All right, let's go ahead and look at these first 2. What's common between those? Well, 4 and a 3 have nothing in common, but everything has at least 1x. So we take out that 1x, okay? And then what's left? Remember, it's division. 4x squared divided by x would be 4x. 3x divided by x, we get rid of the x, so it's plus 3. Now, there's a reason why I did this one where I did, okay? That plus sign carries down. And if you look at these 2, some people run into a red flag here, but there's nothing in common. Well, when there's nothing in common, remember, what did I say? What number is always common with everything? Ichiban! There's always a 1. So we're going to put a 1 right there. And if you divide both of those things by 1, what do? You get the same thing back. Now, why is this good? If I compare this to this, what do you notice? Yeah, they both have a 4x plus 3. So that means I did it right. Okay, and whatever they have in common, you write down as the factor. And then what's left? An x plus a 1. That goes in the other factor. Boom, donezo. Now, come on. Challenge yourself. Get B on your own. If you can get B on your own, you are monies. You can do it. All right, here we go. I really hope you guys tried B. I'm going to do it now together. I'll go kind of quickly because I'm sure you tried it on your own. Hopefully you said all 3 of those. There's nothing in common. So then I'm going to come over here to Masawa. 2 times 6 is 12. Middle guy is a -7, right? Okay, so let's check this out. Whew, a lot of ways to get 12. All right, let's see. 2 and 6, 12 and 1. 3 and 4 gives me a 7. Oh, Mr. Tanaka said earlier, if it gives me the number I want, but I need it to be a different sign, it means just change those bad boys. And believe it or not, that works out, doesn't it? How do I know that works out? Well, because a -3 times a -4 is a +12, but if you combine them, you get a -7. So what do we do here? We take the first guy, we take the last guy. we write down another way to get negative 7x, which is a negative 3x and a negative 4x. Now, there's a curveball that's going to be thrown here because what sign separates those two guys? A negative. And whenever it's a negative, some of us make mistakes, okay? But let's go ahead and group these guys. What's common here? 2 and 3, nothing, but there is an x. So if I factor that x out, that's what I get. That negative sign carries down, remember. Now, what's common between a 4 and a 6? They both have a 2 in it. Okay, so that means I'm going to take out a 2. But if you look very carefully, it's like I'm taking out a negative 2. So what is negative 4x divided by negative 2? What is a positive 6 divided by a negative 2? Sweet! How do I know I did it right? Same thing in the parentheses. So remember, we write down what is common. Okay, we're factoring that out. Factor out, factor out. What's left? An x that goes in the other factor, minus a 2. Man, if you got that on your own, kudos to you. Great, amazing job. Honestly, absolutely amazing. All right, if you didn't get it, let's see you in the morning so that you can continue to dominate the beginning of Algebra Dos. All right, here we go. More practice problems there. We're going to do a ton in class, you guys. But we're finishing off the day with what we call the difference of two squares. It's like a little special scenario guy. All right, so here it is. Let's say we have x squared minus 4 squared. Whoa, what the what? Come on, Mr. T. Let's say we have x squared minus 4. Okay, is that a difference? Difference means minus of two squares. And if you're at home, you're going to say, yes, it is, because I could rewrite this problem as x squared minus 2 squared. And whenever you can write something as a difference of two things being squared, then it's a special factor, okay? And it's just an x minus a 2 and an x plus a 2. It's like a super fast way of dealing what we call, and these guys are special. We say it's a difference of two squares. Okay, I'm just going to rattle off a whole bunch. X squared minus 9. Is that a difference of two squares? Well, sure it is, Mr. T, because that's x squared minus 3 squared. Well, what did I say? I said if you could write it as two things separated by a subtraction sign or a difference of two things being squared, then it's just x minus 3x plus 3. Now, some people are going to say, Mr. T, they wrote that the other way. Well, what did I say earlier? Okay, it doesn't matter what order you write those in. Multiplication is commutative, so you can flip-flop those bad boys. It's like saying, is 4 times 5 the same thing as 5 times 4? You better believe. All right, two more. Okay, two more. What is x squared minus 49? Some of you guys are going to get so good, you're going to say, oh, that's x squared minus 7 squared, which means it's just x minus 7x plus 7. Boom, dunzo. There's only one way this could get a little bit tougher, and it's our last problem of the day. What do you notice that is the difference? Well, that is 25x squared minus 49. Well, that 49 I could write as 7 squared. But I have to be careful with this first part. You have to write it as something squared. And here only the x is being squared. But this is really like 5x because they're both, right? I want to square both of those guys, right? So in another way you could have written that is that's 5 squared x squared minus 7 squared. So what would that final answer be? Well, that would just be what is being squared? What is being squared there? What's being squared? A 5x. What's being squared here? A 7. What's being squared here? A 5x. What's being squared there? A 7. Difference of two squared. That's it for today. That was kind of longer. Aloha. You guys dominate these videos. Please come in for help if you need it. And continue to work hard. Watch these videos. Do that math Excel and come focused, ready to go. Aloha.